All right. So for these examples, we're going to go over interpreting similarity statements. So let's look at A. In the diagram below, triangle MNQ is similar to triangle PNO. Find the scale factor from triangle MNQ to triangle PNO. So let's interpret what this means. MN, based on this statement, is going to be proportional to PN. So the sides that I just highlighted in yellow. And NQ is going to be proportional to NO. So those sides are going to be corresponding to each other. So if we're trying to find the scale factor from triangle MNQ to PNO, what we're going to do is we're going to put these into a ratio. We're going to put 10 over 12, and we're going to put 15 over 18. And we're going to divide those numbers. So 10 divided by 12 is 0.83. And if we double check that, when we do 15 divided by 18, we also get 0.83. So this is known as my scale factor, this 0.83. So if I take 12 and I multiply it by 0.83, I'm going to get the side of triangle PNO. Okay, let's look at part B. So in part B, they tell us that triangle RST is similar to XYZ. So that means that RS is going to correspond with XY. ST is going to correspond with YZ. And RT is going to correspond with XZ. They want us to find the scale factor from the larger triangle to the smaller triangle. And so what we can do is we can put these in two ratios. So we're going to put the smaller over the larger. Smaller over the larger. And we can find the scale factor from taking a pair of corresponding sides and putting them into a fraction. So for example, 15 over 25. And when I do 15 divided by 25 on a calculator, I get 0.6. So this is my scale factor. So I can take that 0.6 and multiply it by all of the sides in triangle RST, and it'll give me the sides of the smaller one. So for example, if I do 20 times 0.6, this gives me 12, which is exactly what we have for the smaller triangle. And if I do 30 times 0.6, that's going to give me 18, which is what we have as well.